To perform testing and simulation of air circuit breakers, ACBs, a range of specialized tools and equipment are used to assess functionality and safety. Below is a breakdown of the tools used and their functions, along with a step-by-step approach for testing. ACB's tools and equipment for testing. ACB primary injection test set function simulates real fault conditions by injecting high current into the ACB to test the tripping characteristics for overcurrent, short circuit, and ground faults. Steps: 1. Connect the test set to the ACB terminals. 2. Inject a current that exceeds the ACB's rated current. Point 3. Observe the breaker tripping at the specified current level to ensure proper functioning. Point 2. Secondary injection. Test set function. Test the electronic trip unit of the ACB by injecting simulated signals, current, voltage, to verify the operation of protective relays without applying high current. Steps: 1. Connect the test set to the trip unit. Point 2. Inject low-level signals mimicking fault conditions. Point 3. Monitor the relay's response and ensure the breaker trips as required. Point 3. Eng'g insulation resistance tester function measures the insulation resistance of the ACB to ensure that there are no leaks of current across the insulation, which could cause faults. Steps: 1. Disconnect the ACB from the power source. 2. Connect the Eng'g leads to the ACB terminals. Point 3. Apply the test voltage and measure insulation resistance. Point 4. Ensure the resistance is within the acceptable range. High resistance values indicate good insulation. 4. Voltage tester/multimeter function measures the voltage levels within the ACB circuit to test undervoltage, overvoltage, and reverse power protection settings. Steps: 1. Set the multimeter to the appropriate voltage range. Point 2. Connect to the ACB's input and output terminals. Point 3. Measure and verify the voltage levels against the ACB's rated voltage. Point 5. Current transformer (CT) analyzer function verifies the performance of current transformers, which are critical for accurate current sensing in ACBs. Steps: 1. Connect the CT analyzer to the ACB current transformers. Point 2. Run tests to measure CT accuracy, ratio, and phase shift. Point 3. Ensure the CTs are operating within their specified parameters. Point 6. Time current characteristics tester function verifies the timing of the ACB's trip mechanism by simulating fault conditions and measuring the time taken for the breaker to trip. Steps: 1. Apply the test current to the ACB. Point 2. Measure the time delay for the breaker circuit. Point 2. Operate the breaker, open and close, and measure the response time. Point 3. Ensure the breaker operates within the manufacturer's specifications. Cebu Woodward Electrical Eng'g Rewinding Workshop.